Okay, everybody, we're going to pick up where we left off with our look at collections here. I want to start today by just reviewing where we're at. So this is some of our scrap notes on collections that we've done over the last several weeks in preparing this large sort of examination of collections. But the basic core of it is that we created a node class which makes a reference to another node class. This node class stores data. That data, we happen to make a generic data type so that we could make the linked list that we're creating something that we could reuse multiple times. We also make this what's called a doubly linked list by also making the node class make a reference back to the previous node that it would be linked to in the list. The linked list itself was this collection of nodes linked together. The first node in the list obviously would link back to nothing, which would therefore have a link to null, and the last node in the list would have a link in its next node to nothing, also linked to null. We needed an entry point into the linked list, so we actually made two entry points, one at the front or the head of the list and one at the back or the tail of the list. And this is what we've done in our examination of the linked list class. Okay, the last method we wrote was the add after method. So now we're going to write an add before method. And my advice is let's just copy and paste the add after method and just change the name of it to start to add before. Okay, so let's examine some of the changes we're going to have to do to make this an add before method. We're still going to have data. We're still going to have an index to add it before. We're still going to check to see if the data is null, and we're going to return false. We're also still going to check to make sure that the index number is in range. So that code stays the same. Now, this part obviously is going to change here. If the index is equal to spot 0, we're not going to add it to the back of the list, but we're going to add it to the front of the list. So this is another way we can do just the same way we did an add after, where we check to see if it was at the end of the list. Now we're checking, to see that it's at the back of the list. Now, the rest of this code will be similar as well. We'll still make a node, insert the data in it. We'll still get the spot we want to insert before by getting current to the index number by using getNode, our built-in method. But then these lines are going to change, these 4 lines. This line will not. The length will still go up. But here, instead of going to the next, we're going to go to the previous node. And instead of current.next, it's going to be current.previous. With the one with the double reference, it's again going to be a switch. It's going to be current.next.previous, or sorry, .previous.next instead of the other way around. And similarly with these two, next is going to go here, and previous is going to go here. Okay? So this is a way we can look at it is, again, we're essentially reversing the logic. .previous equals .previous, .previous.next equals node, .previous equals node, and .next equals current. And that's going to be our add before method. It's essentially a reverse of the logic of the add after method. Okay. Now, if you recall, we had a wrapper method called add, which automatically added things to the back of the list. That's just the sort of the natural way we did that. So we're going to make another wrapper method, public void add, overload add, but this time we're going to give it tdata and int index. So with this one, as a wrapper method, we think, well, which method by default would it call? And I think the answer would be that it would add it after. So that would be the fact that when we just say add with an index, we're really meaning that we're adding it after that spot. So it's just a wrapper method for that. All right. Now it's time to start looking at removal of nodes. So let's start with a big method, a public method. This method will actually return the object it removes. So we'll make it a T method called remove. And we're going to give it the index number of the spot we want it to remove from the list. So it will not only remove this spot from the list, but it will return what it stores. Okay. All right. So first of all, if that index is not in range, so if that index number is not in range, let's just return null. There's nothing to remove, and there's nothing to remove or to return. So this is a quick error check on that index number. So from this point forward, we know the index is valid. So if it's an empty list, we've already taken care of that. If this number is out of range, we've taken care of that. Okay. Now, there's a couple other simple ones as well. If the index I'm asking for is index 0, that's the front of the list, I can just return remove the front, which is a method we already wrote, which not only removes the front but returns it. So that just fits in nicely that we can do that. Similarly, we can also check to see if the index is at the last spot. So in other words, if it's at length -1, so if it's at that spot at the end of the list, let's just remove the back of the list and return it. Okay, so these are just some quick little methods we can do right at the front here that just sort of check those simple scenarios. If it's out of range, return a null. If it's spot 0 or the end of the list, we just remove the front and the back and remove those. However, if we make it through these first 3 if statements, we are now removing something from inside an internal portion of the list. Okay, so let's get there. So we're going to make a current node equal to get node. Our good old get node method gets us to the spot that we need to remove. Remember, we've already checked to make sure that this index number is in range. Okay? Now, at the end of this method, we'll be returning current dot data. That's the data we want to return. We do, however, have to cast it as data type T as we return it. So that will happen at the end of it. Right as we remove it, we'll make sure current's data is returned. We also know that the length of this linked list has to go down by 1. That for sure has to happen. But what goes in between is the actual way we manipulate the nodes and make them move around one another. So let me diagram this. So we know we're not dealing with the front of the list. We're dealing with something inside the list, somewhere in the middle. Okay? So we can assume that the links are in place. And this could be linking to a bunch of other nodes. Similarly, our previous links are in place. And similarly, this could be linking to a bunch of nodes. Okay? We've now created something called current. And current is referencing the node we want to delete right here. We also don't have to worry about the data. We've already taken care of that. So what we have to do is several node redirections. This reference is going to have to redirect around the deleted node to here. In other words, not making this a valid link anymore. This reference is going to have to link around here. In other words, making this a no longer valid reference. Then we're also going to have to deal with the node current itself, and we're going to have to sever this link. In other words, making this a null. And we're going to have to sever this link, in other words, making that a null. So there are 4 lines of code that are going to be needed to make that happen. All right, let's take a look at what those lines would be. So one of them would be this, and it involves a double reference. Current dot previous dot next equals current dot next. What I would be doing with that one would be this, okay? Here's current right here. So if I say current.previous, now I'm over to this node. If I say current.previous.next, I'm talking about this red line right here. And I'm saying what it becomes is current.next. So it's performing this line right here. That's what that is doing. It's doing that line right there in that first line. Okay? Next up, current dot next dot previous equals current dot previous. Okay, so let's examine what that line is doing. We start at current. Okay, we say current.next. So now we're moving to the next node. And then .previous means we're talking about this green line right here, and we're saying it's equal to current.previous. So we just performed that green line right there. Okay? So we did the top and bottom links there, and now all that's left is to sever the links inside the node itself. So current.next equals null, and current.previous equals null. But we can actually do that in one line if we want. If we want to get a little fancy here, we can say current.next equals current.previous equals null. So we can actually do that in one line. We can perform both severs here. Okay? And that should allow us to remove a node. Okay? So that's the code there that we want to use to remove a node. Now before we go to testing, we're going to write a couple other quick methods and then do a bunch of testing at once. Okay? These ones are pretty simple. So we're going to, actually no, let's do the testing right now. Okay, so let's go to our collections test, and one of the last thing we did was add after. So I'm going to run this code to see what our linked list right here was looking like. Looks like we had just added a thing in the last one. So okay, so here's our linked list right here. Okay. So first of all, let's test our add before. Let's try to add something before graveyard. So I'm going to say list1 dot add before. Okay. And I'm going to put the word cheese. Okay. And I believe that was spot 2. I'm going to add it before spot 2. And then I'm going to output the list again. Let's see what we got. So 0, 1, 2, graveyard was at spot 2, and I said insert cheese before that. And you can see here, there it is. It's before graveyard. Now let's edge test this a little bit. 0, 1, 2, 3, 4. If I tried to insert it before the very last node in the list, cheese, it would. Also, I'll edge test it with spot 0. What happens if I try to add it before the very first spot in the list? It worked. And then, of course, one out of range, 10. It didn't do anything to the list. Okay? So that was some quick edge testing. We know it works. Now, let's do a remove. Whoops. List1.remove. And let's pick spot 1 to remove. And since we return that value, since we actually output it, let's just spit it out as we remove it. So we'll remove it like that, and then output the list itself to make sure, one, that we're getting it returned to us properly, and 2, that the list has actually changed. So now I'm saying remove spot 1, and let's see what happens. So it's outputted Juniper, and it said Juniper was at spot 1, 0, 1. That's correct. So it got the right spot to remove. And you'll notice the list after it's been removed, that Juniper no longer exists in the list. All right, let's edge test that a little bit. So what if it was 0, 1, 2, 3, 4? What if it was spot 5 that I asked to remove, which is the very end of the list? So it's got cranky, which is the end of the list, and you can see it's been removed. And then let's try to remove spot 0, the front of the list. And there you see dog has been removed there as well. So we've tested both edges. Let's test outside the list as well. Try to remove spot 10. And we're getting a null value, and the list is remaining untouched. Okay. So we've got an effective add before, add after, and remove method in place. We could also test this one, but since it's a wrapper method, we're going to assume it works. All right, next method up that we're going to write is a public integer method called first index of. It's a search method. Where's the first spot where a piece of data is found? Okay. Now, before I write this method, just stub it in so that it doesn't yell at me. Let me just show you the list again. So here it is, dog, cheese, graveyard. But what I'd like to do is maybe put the word dog in a few places in the list. Okay? So it's not just occurring once. So I'm going to add the word dog before spot 2 and before spot 5. And then let's output the list and let's see what it looks like. Okay, so I have dog here, here, here. Okay, and actually I'm going to remove it from spot 0 as well. Although I don't need to output it, so I'm just going to remove it without outputting it. Okay, so here's our list. We have dog in the list twice, at least twice. It could be multiple times. So I'm going to ask for the first index of dog. Okay, so let's flesh out this method. We're going to make a node current equal to the head of the list. Okay, so there. We're going to make an index number equal to 0. The node will travel through the list. The index will count as we go through the list, while current is not equal to null. We'll start our loop. The end of the loop, if we make it through the whole list and get to null, we're going to return -1. That indicates that it is not in the list. Okay? So before we put any logic inside the while loop, we can kind of test that. So we could say, okay, we're going to output that the dog is located at list1 dot first index of dog. And right now it should give us a -1 because we haven't written that logic yet. But let's just test that. Oh, we're hitting an endless loop. That's what's the problem. So better not test that yet. I guess if I took the while loop out, that would just give us the -1. Okay, so now let's focus on this while loop. If current dot data dot equals the data I passed, then I just found it. This is the first spot. So I'm going to return the index right there. But what also is important in this method is I need to advance current. So current equals current.next. That is important. But in addition, since I'm counting spots, I also have to increase the index. So it also goes up. So now when I run this, it says that it finds dog at spot 1, 0, 1. That's the first spot it found dog. So that's our first index of method. But what if I want to find the last index of it? So my advice is let's copy and paste and change first to last. I'm going to jump over to my testing code for a second, and I'm just going to call that as well the last index of dog. And right now the two methods are identical, so they're both giving us 1. So we're going to change this now. And with our knowledge of linked lists, we can think, okay, instead of starting at the head of the list, I'm going to start at the tail of the list. Instead of starting my index count at 0, I'm going to start it at the last number, which is length -1. The loop will still work the same because I'm still going to keep going till I hit a null. The if statement will still work the same because I'll still, if I find it, return the index. The returning -1 will be the same. These two lines, though, will change because now I'm moving backwards through the list. So now I'll go to the previous node, and my index number will go down by 1 each time. Because we made a doubly linked list, this method becomes a lot easier to implement. And now it's saying it found the last index of dog at spot 4. 0, 1, 2, 3, 4. So it worked. There's dog right there. There's dog right there. First and last index. Okay, we probably should edge test this a little bit. So, for example, instead of dog, what if we look for cheese? Okay, so I'm going to look for cheese, the first and the last index of cheese, and they should be the same because it finds cheese at spot 0 both times. Okay, could also look for cranky, and again, it's found at the edge on spot 5. And then I'll just look for 2 non-items in the list, and it's finding -1 in both cases, right? Because those are not within the list. Okay, so we've effectively tested that method, I think, pretty effectively. All right. In addition to our remove method where we just said remove an index, let's expand on a different remove method now. All right, so this will be a public, sorry. Okay, Boolean remove method. Okay, so it's a bit of an overload because this one requires data. So with this one, I'm not removing a specific index. I'm removing data out of the linked list. Okay, and what this will essentially do is remove the data the very first time it finds it. Okay, so first an error check. If the data equals null, there's nothing to remove here. So we're going to return a null. Or sorry, we're going to return a false. I can't remove null data from a list. I don't allow null data in my list. Okay? All right. Now, I don't need to check to see if this is in range because this is not an index number. Okay? So I need to find the first spot this data occurs so I can use the method I just wrote. Int index equals first index of this data. So that's the first spot that data shows up. However, if that index equals -1, there's nothing to remove. It wasn't in the list. So I'm going to return a false. If it is in the list, then I'm going to call my other remove method, remove that index, and finally return true. So because I already have a remove method and I have a first index of method, the remove method here becomes a lot easier. Let's put it to the test. Let's remove dog. List1 dot remove dog. So I'm going to remove dog, and then I'm going to output the list to see that dog has been removed. Okay, and let me just pull that up a little bit. Cheese dog, so now dog is out of there. But the second version of dog is still in the list. It just removed the first occurrence of dog. Let's also write a method to remove the last occurrence of dog. So again, let's just copy and paste this. It starts off the same way, but we'll call this one remove last. This one's just remove, this one's remove last. Okay, if the data is null, return false. Index is now equal to the last index of the data. This part's the same, and the rest, basically the entire method is the same. The only difference is this versus this is what changes. Okay, let's put that to the test by changing remove to remove last occurrence of dog. And now the first place dog is still in the list, but the second place dog occurred is not in the list. Finally, well, not finally, but next, let's make a method to remove all the occurrences of dog. Public, we'll make this one a void method though. Remove all of this data from the list. So any place you find the word dog, let's remove it. For this one, I'm going to use a while loop. And I'll say while it contains the data, remove that data. Whoops. And that's it. That's all I need to do. Because I can call upon this method to keep removing it, removing it, removing it. And my other method contains will just keep checking to see if it contains the data. So I like the way this method works because it's just so clean looking. And let's see what happens if I call remove all the dogs from the list. And now this dog is gone, and this dog is gone. I've removed them all. Okay? So that's some nice testing there. Now again, if I just put in garbage, it doesn't affect the list. The list remains untouched. Okay? It's only when I give it valid data that our code holds up and does the job we wanted it to do. Let's do one more remove. Public void remove all. So it's an overload. But this time I'm going to give it an array of items to remove. A whole group of items. So before we write this, let's see how I would test that one. Okay? So we know remove all works here. But what if I made an array of strings? A string array called items equal to, and I'm going to do it this style of array creation. And I'm going to give it this, this, and this. So let's say it's dog, removing all the dogs, cheese, remove all the cheeses from the list, and cats, which we don't even have in the list. But let's say those were the array of items, and I said remove all of these items from the list. This would be the idea of what we want. Now, I play this now, it's not going to work. The list remains untouched. But what I want to have is both cheese and dog and all the places where cheese and dog exist in the list removed. So all we need to do for this one is loop through our items. Okay? And you know what, for fun, let's make this an enhanced for loop. So let me back up. I'm going to type FOR control spacebar and use this version of the enhanced for loop. For each item in items, remove that item. Okay? And I'm going to actually switch that to remove all of those items. And that's it. That's all I need to do to make this method work. Let's test it. And cheese, dog, and all the dogs have been removed from the list. Just that simple. Okay. How about a little method next called clear? Public void clear. Clear, like finalize, just wipes out the list. So something like this. Node current equals head of the list, while current is not equal to null. So we'll go through the whole list. Okay. Current equals current.next. That will advance it. Okay. But to clear it, what I'm going to do is I'm going to make a node called next equal to current.next. So in other words, down here, I just have to say current equals the next node, because what I'm going to then do is take current dot finalize it. So it wipes out the current node, and then it advances it ahead. And then finally, I'm going to finalize the whole list, which, as you know, sets things to... This is basically a very deep way to wipe the list out. Let's see if that worked. List1 dot clear, and then output list1. Let's see that we have an empty list at the end of it. So it just cleared this list out, which again is basically a repeat of the finalize method. It's just a little bit deeper even than finalize in terms of calling the finalize method right within the node class, which we wrote, if you remember, right in the node class we wrote a finalize method which sets the data to null and sets the references to null. So it's calling that, and then it's also calling the finalize method of the linked list, which just quickly find, well actually I'll do it the easier way. Finalize, okay, length equals null and head and tail equals null. So that's what we're looking at here as we clear our linked list. Okay, time for one or two more methods to wrap up here. Okay, so let's do another method. This one's going to be called public void retain all of T array items. So this would be the opposite. This will not remove them all, but retain all the items in the list. Okay, so the first thing I'm going to do is clear the list, and then I'm going to run an enhanced for loop. Whoops, wrong one. Through all the items, and I'm going to just re-add that item into the list. Okay? This is not the perfect version of this method, but let's just kind of see what I mean by this. Instead of removing them all, let me get rid of that clear test, I don't need that. I'm going to retain all the items in the list. So here's the items, I'm going to retain them all instead of removing them all. And you can see there, it just retains the items that I said instead of removing them. Now, as you can guess, dog occurring twice in the list means it probably should have retained dog twice, plus cats isn't in the list, and yet it retained it. So this is a method that I'd actually like to leave for you guys to possibly improve yourselves as a better way to clear out the list, except for the ones we have there. But I just wanted to put it in there for our testing purposes. And I'm going to switch this back to, well, actually I'm going to get rid of all this for now and just stick with the list that we have at this point for the rest of our tests. So that's a pretty good list to test with. All right. So that's retain all. Now let's make maybe a more useful method than retain all. Let's make a little public Boolean method called contains all. This will be essentially a search, but through a whole array of items. Oh, that makes me think that I shouldn't have erased that array. Let me go back and get the array there. Yeah, okay. We've got the array. Okay. So it's going to check to see if all the items in the array are in the linked list. Okay, so we can actually do a couple little error checks first. If items, the array, is actually a non-existent array, it's a null array, let's just return false. I don't need to go any further. I'm not checking that array. Also, if items.length equals 0, that's basically an empty array, I'm not going any further. Okay? So if it's a null array or essentially an empty array, I'm not going any further. However, if I do make it through those first two if statements, now I need to actually look through. So I'm going to run a for loop through the array. This time I'll do a standard for loop, items.length. Okay, not the enhanced, just a standard one. And if contains, another method we have, what's in items at spot I, if that does not contain that item, so I'm going to put the not there, well, then I just return false. And if I can make it all the way through that for loop, I can finally return true, that it contains all the items in the array. All right, so I'm going to test that here by outputting list1 dot contains all of those items. Now, what we should get is a false, because it does contain dog and cheese, but it does not contain cats. So let's see. False. Okay? If I take cats out of the array, so it's just dog and cheese, we should be getting a true because it does contain that. And it does. Okay? So that's some quick testing there on that little method right there. All right, one more. Well, lots more, but let's make another one now. This method, public int number of. So this is not only search, but it counts how many times this data occurs within the list. So for example, with the word dog, it should give us a 2 because it occurs twice in the list. So we're going to start with a counter. Oops. Started at 0. At the end of this method, we're going to return that counter. So in other words, if it never finds it, it will do that. Okay. One of the things we can do is check data right away. So if data equals null, let's just return, well, we can just return 0. That would be a quick way. Okay. That there's no data in the node, in the list. Okay, but now let's say node current equals the head of the list, while current does not equal null. Okay, if current dot data dot equals the data that I passed to this method, then the counter goes up by 1. So counter increases. Within the while loop, I still need to move my current ahead. Current equals current dot next to move current to the next node. And then at the end, I return the counter. Pretty simple method, I think. Again, using these while loops and current equals, we've been doing this a lot, so it should be pretty familiar to you now. So let's try it. I'm going to output list1 dot number of dog. How many times does, whoops, does dog appear within the list? I should get a 2, and I do. Now let's try one that there's only 1 in the list, cheese. And I get a 1, and let's try one that does not exist in the list, and I should get a 0. Okay? So the number of method is functioning properly to give us, whoops, the correct number of times it's in the list. All right, so now that we're finished number of, the next method we're going to write is a add all method. So public void add all. And what we're going to do is we're going to give it a linked list called list, and we're going to add all of this list to another list, to the existing list. So this is where we have a linked list as a parameter, and we're going to add it to that one. So let me show you what I mean by in the testing. So if we print this right now, you know we have our list, cheese, graveyard, dog, etc., etc., etc. And when we first made a linked list, way back at the beginning, we had 2 of them, linked list 1 and linked list 2. We've been sort of playing with these lists through the code. So let's output those 2 lists just to see what they look like. So I'm going to take an output of list 1 and an output of list 2. Okay. Oh, but list 2 is not strings. That's a problem. Okay, let's make a list 3. I don't think we have a list 3 at this point, do we? No. Okay. So before we output these 2 lists, let's make a linked list also of strings, list 3 equals a new linked list. And let's add a few things to that list. List3 dot add. Let's put some superheroes in it. Spider-Man. And Superman. Batman. So sexist. And all right, let's not be too sexist. Let's make Wonder Woman. Okay, and then I'm going to output list 3. So here's list 1 and list 3. Okay, but the idea is going to be, what we're going to do is we're going to say, hey, list 1, add all of list 3, and then let's take a look at what list 1 looks like now after we've done that. So that's what we're going to write right here. We're going to add all of this list to our existing list. So to do this, we're going to use a for loop and go to list.size. We're going to get a particular item from this linked list. We're going to get spot I. We have to cast that. Oh, no, actually, we don't have to cast it as a. So again, when I say list.size, that's incorrect. It's this, or sorry, no, it is list.size. What am I talking about? Okay, hang on, let me go back. Pardon me. So the item comes from not this.getI, but list.getI. So I get it out of the list. Okay. This is where I have to cast it into data type T. Then I go to this and add that item. However, I can do these 2 lines at once by just taking this part, putting it in here, and then this temporary variable is not necessary. So this would be our whole add all method. I add it to this, I get it from the list. I loop through the entire list. So if that's in place, let's see what happens. So now I have cheese, dog, graveyard, dog, cranky, and then it added Spider-Man, Superman, Batman, and Wonder Woman. Okay. So I can now combine one list with another using my add all method. Let's overload that. public void add all linked list, but we're going to put an index in. So now what I'm saying is, okay, I want to add all these items from this list, but I want to add them at this particular index. So if I go back to my test, what if I said add them all at spot 3? Okay, so hang on, let me just play it first so you know what I mean. So this is the original list 1, and I say add all of this list at spot 3. So it would go 0, 1, 2, 3, and it would add them all right there. So that whole list would get added there. Okay, so to do this, what I'm going to do is, again, I'm going to run the for loop. I'm going to go through list.size, so it starts off the same. Okay, it's going to say this.add, but now I'm going to call add after, and I'm going to cast t list.get spot I comma index. So now I'm calling the add after method, but I have to do one more line of code for this logic to work. I have to advance the index so that it adds it after it, spot after spot after spot. So the index is advanced. So now, putting that to the test and saying 3, add the whole list after spot 3. Now you can see 0, 1, 2, 3. So after this word, the other list should be getting inserted in there. Oh, but it's not. It is not being inserted. Oh, pardon me. This should be I right here, because that's going to keep looping. So now after this, here comes that whole list: Spider-Man, Superman, Batman, Wonder Woman, and then the rest of the list, dog and cranky, continue. Okay, so now I can insert or add an entire linked list into the middle of that linked list. That's pretty cool. All right, next method up, a very useful method. Public linked list is the return type, and it's going to be called SubList. This is where I'm going to pull a linked list out of our linked list. And I'm going to give it two values, int from, int to. So from one spot to another. So what I mean by this is, if I said, give me spot 0, 1, 2, that's from spot 2 to this spot, 3, 4, 2 to 4, it would pull out this portion of the linked list and give it to me as another linked list. Okay? So I'm allowed to pull out a sub-list from my linked list. Okay, so the first thing, these two integers have to both be in range for this to work. So I'm going to check that. If not in range, the from variable is not in range, I'm just going to return a null. There's nothing to get out of this list. Similarly, I'm going to also check the to variable the same way. If the to variable is not in range, return a null. Now there's another option. What if I give it spot 7 and 3? That doesn't make sense because this number has to be smaller than this number. So I have to check to see if the from variable has to be, or in other words, if it's greater than the to variable, then that's not possible. I'm going to return a null. Okay? So in other words, if this was a 5 and this was a 2, this one would be greater than this one. That doesn't make sense. They can be equal though. I can say give me 5 to 5. That would just be one spot in the linked list, but that would be valid. So, but if it's greater, that's an invalid. If it makes it through these first 3 if statements, now I know I have 2 valid numbers. So here's how I'm going to work it. I'm going to say give me a linked list, a new one. So I'm going to create one called list as a new linked list. So I build up the new linked list. At the end of this method, I'm going to return it. In the middle, what I'm going to do is run my for loop. But here's how the for loop's going to work. I don't start at 0. I start at from. I don't end at 10. I end at when I'm less than or equal to 2. And I just say list.add this dot get spot I. And that is my SubList method, where it gets from one list and adds it to the other by looping to the specific integers that I've asked for, which have been error checked to make sure that they're all lining up properly. Okay, let's see how this would work in our collection test. So we have this big list, list 1. Let's make a linked list, data type string, called list 4. And it's equal to, go into list 1 and give me a sublist from spot 2 to 5. So it's going to grab spot 2 to 5, and then I'm going to output this new list 4 that I just got out of list 1. Let's see what happens. Now, I just printed list 1, so let's see what happens here. So here's list 1, and I just said, oh, here's my sublist. Okay, so I said go from 2 to 5. So 0, 1, 2. So the first thing should be graveyard, and it is. Then this one, 3, 4, 5. Superman should be the last one, and there it is. Now we should probably edge test this. What if we went from 0 to 5? Or how about just 0 to 2? Okay, so it grabs those ones. Okay, so 0, 1, 2. How big is this thing? 3, 4, 5, 6, 7, 8, 9. Oh, okay, so what if we went 0 to 9? That should be the whole list, but we don't know that. But it should be grabbing everything, which it did. What about 0 to 8? One less than that. Edge test that. Okay, that looks good. What about I go all the way to 9, but I don't start at 0, I start at 1. Okay, that looks good. Missed the first one. Okay. What if I go out of range? What if I do this? 10 to 9. That doesn't make sense. Okay, so now we have a null. That worked. What if I went spot 3 to 3? That should be valid. That's one spot. There it is. Okay. What about 3 to 30? That's out of range. And it worked. Okay. So lots of different scenarios there all seem to be able to pull out the sublist properly. So that's a very useful method. Next up, public int array called all indices, which is the plural of index. So what I'm doing with this method is I'm finding the data and all the different spots it occurs. Okay, so here's what I mean by this. Take a look at this list. Here's dog, and dog appears twice in the list. Actually, let's use our new list 4 for this. And let's put Superman in the list a couple different places. So I'm going to take list 4 and make some changes to it. I'm going to say list 4.add after, so I'm going to add Superman after spot 0, and add a couple other places after spot 2 and after spot 5. And then I'm going to output list 4 again. Okay, so here's list 4. And Superman occurs here, 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 here. But I am going to put one last thing at the end. Dot add to the back. Geez. Okay. So there. Now, Superman is in the very last spot in the list, but it occurs 1, 2, 3, 4 times in the list at different places. So what we would be getting back would be spot 1, spot 3, spot 5, and spot 6 would be returned to us in an array of all those spots. So the array would be 0, 1, 2, and 3 spots. Okay, so here's how it's going to work. The way this method's going to work is we're going to start off with a count. We're going to count by using our number of method. So we're going to count how many times the data occurs in the list. That will give us the count. We'll use that count to build our array of indices. Equals a new integer array based on that count. Whoops, indices. Okay, so at the end of this method, we'll return those indices. That array will be returned. But what we need to do is find all the spots where it occurs. So we're going to start with an index variable. We're going to make it 0. We're also going to make an I variable equal to 0. So kind of like a looping variable. We're going to have a node, current, starting at the head of the list. While current does not equal null. So we have to go through the whole list. Okay, we know we will be advancing current. Current equals current dot next. That will happen. The I variable will be increasing like it would in a loop. We will have an if statement. If current dot data dot equals the other data. Then I just found it. If I find it, then into my array indices at spot index, I store the number I, and then index goes up by 1. Okay, so as you look over this method, some neat little logic in there to see if it works. So now we put this to the test. I'm going to create an array of all the spots by going into list4 dot give me all the indices of the word Superman. So this will now occupy this array. So let's run through that array, the array of spots. Okay, or maybe for fun, again, let's use the enhanced for loop. For every spot in spots, okay, I'm going to output that spot. Okay. Let's back up. Let's use the regular for loop. Whoops. Okay, so in spots dot length, okay, I'm going to output that I equals spots, spot I. Okay. And we'll see what gets outputted of all the spots of Superman. Okay, so it says it created an array of 4 spots, 0, 1, 2, 3. But in that array, it stored a 1, 0, 1. It stored a 3, 2, 3. It stored a 5, 4, 5, and a 6. So it was able to successfully locate all the spots of Superman within the linked list. And that's our all indices method. All right, now for some short ones. Public void from array t item. Well, let's call it array. What we're going to do with this method is we're going to generate a linked list from an array. So we start as an array, and then it becomes a linked list. So if we have a linked list, let's wipe it out. Let's finalize it. Then let's go through our entire array. Okay? We use the standard array loop this time. Array dot length. Then we add what's in the array at spot I. And that is all we need to do to generate a linked list from an array. All right, so let's test this. Let's start with an array. Let's pick a different data type this time. How about integer array called array equals, we'll use the standard sort of array method. And we'll put in 10, 20, 30, 40, 50 into that array. Okay. Now, we have a linked list that holds integers. We made one, I thought, it wasn't list 2. Well, list 2 is doubles. Okay, well, let's make this a double array then. 10.1, 20.2, 30.3, 40.4, 50.5. There's some doubles to put in our array. And now we can use list 2. List 2 dot from array. And then we'll output list 2. So list 2 should be built from this array of doubles. And it was. So it built it from the array. Okay? Now, although it might seem kind of useless, we can also do this from method with not an array, but from another linked list. Okay? So the parameter type would change to linked list, called list. Okay? A lot of the code would be the same though, right? It wouldn't be array.length, it would be list.size. Okay? It wouldn't be this simple here to just grab it from the array at spot I. What we would have to do is go to our list and get spot I, and we probably would have to, because it's generics, make a cast into data type T. But other than that, the code should be essentially the same. Okay? So if I was to test that, I could make another linked list, right? Whoops. Of data type double called list 5 equals a new linked list. And then maybe I'll just put one double into there. List5 dot add 3.14. Okay, so it has content, but then I say list5 dot from linked list list 4, which is a different linked list of doubles, and then I'll output list 5. Let's see what we get. Oh, list 4 was the wrong one. List 4 is strings, so let's make that into doubles. There we go. And there it is. Okay, so it did make list 5 from list 4. So it's kind of like a clone method exactly. Okay, now let's go the other way. What if we wanted to turn our linked list into an array? So we're going to make a public data type T array to array method. To do this method, though, it's a little tricky. We have to employ some code from outside of our logic. So we actually have to pass it the array itself as a parameter. Okay. Now, what if we didn't? Right? What if this didn't happen? What you'd probably think we'd have to do is make an array, a new type T array. The size of it would be from the linked list, this dot size, or even the variable length, which is available to us. So that might be easier. Let's just use length. Okay. The end of this would be returning that array. That would be true. And we'd fill the array by running a for loop through our linked list up to the length. Okay. And we'd go into the array at spot I, and we'd go into this linked list and get spot I and store it in there like that. So that works all great, except for this line. We cannot generate an array this way. It cannot be created in this way using generics. So to do this, what we're going to do is we're going to actually pass it the array from the start, believe it or not. Okay. Then what we're going to do is take that array and say it's equal to, and we're going to cast it into a T array, just like we would normally cast anything else. So we're casting it into this, and for this we're going to use something called the array class, which is a class built into Java, dot a new instance. Okay. But let me just back up. This is a method called new instance. The two parameters are the component type. So this is looking for what type T is, okay? So for that, we'll get to that in a minute. Length is correct. That's the second parameter. That's correct right there, okay? But for component type, what we do is we go into the array itself, dot, we get the class, which you'd think would be enough, but it's not. We still have to get the component type from there. So this is a double call there from array, get class, get component type. And then hopefully that should all work together to create an array from the linked list. Okay, so we're going to put this to the test now. So we already have an array, a double array, but let's make another one. A double array, let's just call it things, equals a new double array size 0. So it's basically an empty array. Then what I'm going to say is things equals list5 dot to array, and I pass it the things. So it is originally empty, but when it comes back, it's going to be filled, we hope. So I'm going to run a for loop through things.length, and I'm going to output I equals things spot I. So let's see what comes out of this array of doubles that I got from turning the linked list into an array. And there it is. Okay? It's the same content as the linked list itself. So now I can transition from linked lists to arrays if necessary. So for fun, let's put some of that into some constructors for this class. So let's go all the way back to our constructors. We actually only had one constructor making a default linked list. But now let's overload that. Let's make an overloaded constructor that takes an array. And all I have to call is my fromArray method to generate the linked list right from the array. And we'll also make one that takes a linked list as a parameter. And we change this to from linked list. So two quick constructors that also work with linked lists. Let's quickly put that to the test. So I'm going to make a linked list type double list 6. And I'm also going to make a list 7 equals a new linked list. But this one I'm going to pass it the things, which is an array of doubles. And then this one will be a new linked list. But this one I'll pass it list 6, which is a linked list. So they're all doubles, but this one comes from an array, this one comes from a linked list, and then let's output list 6 and 7 to see what they look like. So using the constructors to build up the linked lists. And there they are. Same list, just keeps getting built properly. So we're all good there. And that concludes the code I wanted to show you about linked list. That's all the methods that I want to put in there. Really now, if you were to look over all these methods we've put into the linked list, it is a very exhaustive list. But I got some crazy news for you. Everything we did has already been done for you in a built-in linked list class within Java. Now, of course, we didn't do it just for that purpose, but so the fact that it's redundant is because normally professional programmers do not create linked lists from scratch. You guys did it to learn it, and because you could possibly be using it for things like submission for final projects. So a linked list data type is already available for you to import from the java.util collections framework. Java defines this framework as the JCF, a set of classes and interfaces that implement commonly reusable data structures. Okay? This should have meaning to you. Both the word collection, data structure, etc., and even framework are things that your experience now, not only using a linked list, but working with advanced classes, gives you better understanding of this advanced data type. Okay? The framework is really a library of code that you can use to import various types of advanced data types to work with, including the list, which includes both linked list and something called array list, which is pretty much the same as linked list, but a few less features. The stack, which if you take the IB computer science course, you'll study. The queue, which you will also start in the study in the IB computer science course. Specifically as well, there's something called a priority queue. And then there's something called the set, including a hash set or a hash table, and the map, which are variations of a tree map, which I somewhat study in the IB computer science course in a slightly different format. Okay, so there are data structures that you obviously are going to learn after my courses with you here in high school. Okay? When you use these things, you will see methods and Java documentation very similar to what you're used to. So to show you that, I think what we'll do is we'll use one of these linked lists. Not the one we've been working with, but a different one. So what I'm going to do is not just say linked list, but I'm going to say java.util.linkedList, like this. This will, by putting this part in the front, make sure that it doesn't use the one that we wrote, but it uses this one that's imported. It's the same as writing an import line at the top. And we'll make it of type string, and I guess we're up to list 8, equals a new java.util.linkedList. Okay? So that's a long line, but now I've generated a linked list of type string, but I'm not using the one that we wrote. So anything I do with list 8, all these methods come from that utility library. So you can see here there's a toArray method just like the one we wrote, and other ones like remove and remove first, etc., etc. Now they're not exactly the same as the ones we did, but they're very close, and there are a few others in there as well. Okay? So, for example, I could add a cat to this list, and then I could output list 8 if I wanted to. And I should see it very similarly outputting very similar method to the way we used with ours. Similarly, if I wanted to, I could create the array list. Okay, and this time I'll do it with doubles. And I'll call this list 9 equals a new array list. Okay. Now when I did this, it probably, if I do it that way, it probably imported it to be able to use this thing. So if I look up at the top here, yes it did. It did in fact import it from the utility library. Okay. So now with list 9, I can call upon its methods. Okay. And again, you're seeing very similar methods in there to, for example, add a double, like 15.898 to list 9. And I should be able to output, well, let's add 2 of them just to make it more interesting. Okay, and I should be able to output list 9 as well to see it as a linked list. Okay, so the array list and the linked list are already written for you. Okay, this is, as I said, in the notes. You can see examples of the Java documentation and the array lists, like I said. Now, one of the nice things about using the built-in one is I do have access to things like the enhanced for loop, which allows me to go through a linked list using an enhanced for loop, which ours didn't have the option of doing. Okay, couldn't have used the enhanced for loop for our version of the linked list, but the built-in one from the Java utility library does allow that. As well, it allows you to work with something called an iterator object, which is something we don't have too much time to look at, but I'm going to show you real quick what an iterator does. Okay? So what an iterator, okay, object does, okay, and iterators will have to be imported, okay, is basically something that's used with lists. But you need it within your list, and our linked list doesn't have iterators, but Java's does. So I'm going to go into list 8, dot get an iterator out of the list. Okay, so this method iterator returns an iterator over the elements in this list in proper sequence. So now that I have an iterator object, I have methods built into it, like next, which returns the next element in the iteration. Okay? Like hasNext, which returns a Boolean, returns true if the iteration has more elements. In other words, returns true if .next would return an element. So it's similar to the .next and .next equals null type code. And you can use iterators to do things like loops. So something like this. I'd say while iterator, oops, dot has the next spot to go to, iterator dot go to the next one. So this would kind of be how it works, okay? But dot next usually returns the object that is stored at the next thing. So I could say, oh, okay, well, list 8 is full of strings. So what if I made a string called the item equal to that, okay? Or the thing equal to that. As always, you probably might have to cast this, okay, just like we did with ours. And then I could output that thing, okay? So in a lot of ways, this works basically like a loop with the iterator. It's not as intuitive as you'd think, but you can see there cat, which was the one item we had in the list, worked. If I was to add more things to my list, other than cat, like let me add a few things. Rat, bat, sat, okay? So then you can see there it's same as the other one, it's looping through the list. So the iterator is another option you can use with linked lists. And this code is in the slide notes as well. With collections, as we wrap up, you can vary linked lists in general. So for example, one of the things that's done with linked lists is to make what's called sometimes a head record or a head node, which stores other pieces of data about the linked list other than just the data itself. Like it might store the smallest, the largest value, the number of nodes in the list, etc. So one node in the list would be a little different, and it holds more data than just the data itself. So it could be combined with the head reference to store multiple pieces of data. This would obviously change up your methods, right? So the head node class would be a different class, and other methods like inserting and remove would need to be changed. Another thing we could create is called a circular list. In this one, rather than point to null, we could have our last node point back to our first node, creating a circular object. Now with this, we'd have to change all our loop algorithms. So instead of saying current is not equal to null, we'd have to say things like current is not equal to top, okay? So it would be something like this. Now this is just a singly linked list, but the last node would go back to the first node, creating a circular data structure. A circular doubly linked list would be the same as what we created, but now the last node would go back to the first node, and the first node would go over to the last node. Something like that. And again, all your algorithms would have to change, and at this point you wouldn't need both a head and tail, because really with a circular object you would just need one entry point, and you could keep circling around the linked list from the start to the end. One use of this would be to create something like a polygon object, where each node could be representing a spot. So maybe you store an X and a Y variable as well. So at this point, the linked list isn't necessarily a linear way to visualize it, because now you're traversing from node to node, but it's not necessarily in a straight line. It could be in a circular line or just some sort of other type of polygon type visualization of the object itself, okay? There are lots of variations on list objects, okay, that are nonlinear. The stack and the queue are essentially versions of the linked list, okay? Moving ahead into things like hash tables and trees that are also nonlinear. They're not lists per se, but this is the beginning of these types of examination of objects that you can study beyond this course. If you take the IB Computer Science course, we do look into some of that, and obviously, if you take computer science beyond high school, you're going to look into this stuff in more detail. Thanks for my look at the linked list and collections concepts.